Okay, so today we're going to look at solving 3 by 3 systems of equations, which means we have 3 equations with 3 unknowns. That's why it's called 3 by 3. Last year in algebra, we did problems like this, where you had something like, let's say, 2x plus 5y equals 6, and maybe 4x minus 3y equals 2. And we learned a couple of methods for solving systems like that. We did substitution, where you had to get one of the variables by itself and then substitute it into the other equation. Or we did the elimination method, where we tried to eliminate one of the variables. So for example, I could multiply everything here by -2, and then it becomes -4x minus 10y equals -12. And then we'd just rewrite the second equation here, and that would allow us to eliminate the x's. When I add these equations together, the x's would go away, and I'd have -13y equals -10. And so then y would be 10/13. So it's called the elimination method because by matching up those coefficients or making them opposite of each other, I eliminate that variable. And so we're going to do something similar to that when we're solving 3 by 3s, but to make the process a little bit easier, we're going to do it in matrix form. So I know you haven't worked with matrices before, or probably many of you haven't worked with matrices before. So a matrix is just an array of numbers, and so we're going to put all of these numbers, all of these coefficients in our matrix. So we're going to just go across and put -2, -2, 1, and 2 for the first equation. So those are the coefficients of x, y, z, and then the constant that's on the right side of the equal sign. And then the next one would be 2, -4, 4, 0. And then the last one would be -4, -4, 1, 6. Okay, that is called an augmented matrix because if I just had these numbers on the right, that would be called a matrix. But since I'm splitting up the matrix with an equal sign, that's called an augmented matrix. Okay, because we have the dotted line represents an equal sign. Okay, so now we're going to go through the process to try to convert this into a matrix that has these numbers. And then it doesn't matter what, we could have A, B, and C for the last numbers. So once I get the matrix in this form with 1s on the main diagonal here and 0s everywhere else, then that's called reduced row echelon form. Reduced row echelon form is what we're trying to get to. So we're going to go through a series of steps. It's kind of like doing the elimination method, but we don't have to worry about the variables anymore. As long as we keep all the numbers in the correct column, then they will still represent x, y, and z. Okay? So reduced row echelon form is what we're trying to get to. Okay? So what I'm going to do at each step, I'm going to put notes in the side to show what we did to get from one step to the next. Okay? So I'm going to start off, and since we want zeros here and here, we're going to start with those. So we're trying to make this into a 0 and this into a 0. So notice that if I just add row 1 and row 2, that's going to convert this one into a 0. And so I'm just going to leave the top row as is, and then I'm going to replace row 2 with what used to be row 1 plus row 2. Okay, so if I add row 1 and row 2, notice that that becomes a 0, which is great. That's what we want. And then this is -6, 5, and 2. When I add row 1 and row 2, that's what I get. So can someone suggest what we could do for row 3 to convert the -4 into a 0? 2 times row 1 plus row 2 would give me -8. But if I multiply it by -2 instead, that's going to give me a +4 and a -4. So I want to do negative 2 times row 1 plus row 3. So I'm multiplying the top row by negative 2 and adding it to the bottom row. And so that's going to give me a 0 there because that would be positive 4 minus 4 is 0. And then do that with the 2 and the negative 4. So top row times negative 2 gives me 4 plus 4. I get 0 again, which is really great because now I accomplished both of those in one step. That doesn't always happen, but I was able to get both zeros there in one step. And then how about 1 times negative 2 plus 1? Negative 1. And 2 times negative 2 plus 6? 2. Okay, so we're looking really good. We got 3 zeros here. Now we need to convert this into a 0. And notice that if I do anything with row 1, that's going to mess up the zeros that we already have here. So we don't want to do anything with row 1 because the negative 2 that's in row 1 will mess up the zeros that we already accomplished. So we're going to try to make the 5 into a 0 only by using row 3 and row 2. Okay, so at my next step, again, I'm going to leave the top one the same. And I'm going to replace row 2. Does anyone see how we can use row 3 and row 2 together to get rid of the 5? Allison? Multiply by what? Jack? Yes. Row 2 minus 5 row 3. Because negative 1 times negative 5 is going to, actually, we want that to be positive 5, don't we? If I multiply this by 5, that'll give me negative 5. Plus 5 will give me 0. So row 2 plus 5 times row 3. Row 2 plus 5 times row 3 will make that 0. And so if I do 5 times 0 plus 0, I still get 0. So I didn't mess up the work that we had already done. 5 times 0 is 0, plus negative 6 is negative 6. Negative 1 times 5 is negative 5, plus 5 is 0. And 10 plus 2 is 12. And then I have 0, 0, negative 1, 2. Okay, so we've done some great work. We got zeros now in 3 of the 5 places that we need. Okay, we've got these 3 zeros. We still need to make this 0 and this 0. Okay, so we're on a good start. We've gotten a good start going here. We need to now get rid of those. Okay, so before I do that, I'm going to make these simpler by changing them into 1s. Notice that we want them to be 1s on the main diagonal. That's pretty easy to do at this step. So leave row 1 alone. Just rewrite it. Now, what can I do to row 2 to change this negative 6 into a 1? By multiplying it by something. Could we just do row 2 divided by negative 6? Okay? Because, see, if you add 7, you're going to mess up that. You're going to mess up the 0 that we have. So we don't want to ever add or subtract. We want to, we don't ever want to add or subtract. We want to multiply rows by a certain number. Okay? So if we multiply by negative 1/6, or that's the same as dividing by negative 6, that keeps the 0 that we want. this becomes a 1, this is still a 0, and this would be -2. So we got the 1 where we want. What can I do to row 3 to change that to a +1 instead of a -1? Multiply or divide by -1, and that becomes 0, 0, 1, -2. Now we're ready to convert these to zeros. And we can do that all in one step by doing a combination of all 3 rows. So if I start with row 2 and I add start with row 1 is what I meant. Start with row 1 and add twice row 2. Does everyone see how that's going to convert this into a 0? And then I could also subtract row 3, and that would convert that into a 0. So I'm going to do it all in one step. So -2 plus 2 times 0 minus 0. Is -2. So the zeros aren't going to change that. Okay? What is -2 plus 2 minus 0? 0, which is what we wanted. Okay? What is 1 plus 2 times 0 minus 1? 0. What is 2 minus 4 minus -2? And let me write it down here. 2 plus 2 times -2 plus 2. 0. So this is 0 also. We didn't need that one to be 0, but it just turned out to be 0. And now we have 0, 1, 0, -2, 0, 0, 1, -2. Okay? We're almost in reduced row echelon form. The only thing we need, it's not that important to have a 1 here, but we're one step away. So to get that in reduced row echelon form, I would take row 1 and I would divide by -2. All right, so if I divide row 1 by -2, now I have all the zeros that I want, the zeros and the ones that I want. And so this is now in reduced row echelon form. And notice now how that just gives us the solutions, because remember this column represents x's, y's, z's, and then the constant. So this tells me that z equals -2. What does this tell me? Y equals -2. And what does this tell me? X equals 0. Okay, remember we have an equal sign here, so that means 1x equals 0. So now we have our 3 solutions. Okay, that took a lot of steps to get there, but it'll get easier as you get more practice with this. So the task is to go through the steps of taking combinations of any rows to try to get, let's go back to the beginning. Remember the first thing we tried to do was get the zeros right here that I have in yellow. After we got that, then we worked with trying to make that into a 0, these two into zeros as well. And then the final step was to try to get zeros up here. And so we'll follow those same general steps each time, but obviously we're going to have different multipliers to try to make those things into zeros. Okay? So what I'd like you to do now is partner up with somebody in your group and put problem 2 in an augmented matrix and keep track of your steps along the way to try to get this into reduced row echelon form. Okay, just take a look. I want to make sure everybody has a good start. Now there are different ways to do this. Not everyone has to follow the same steps. But one thing that's nice about this problem is the 1 in the top row is going to make this a little bit easier, because it's going to make it easy to change that into a 0 and that into a 0 since we have a 1 at the top. For example, one way to make the 5 into a 0 is to to multiply the top row by -5. So we'll say that's -5 times row 1 plus row 2. See, if I multiply the top equation by -5, I'm going to add it to 5, and that gives me 0 where I want it. Do the same thing here. That's if you multiply -6 times -5, that's going to be +30 plus -3 is 27. Multiply by -5 gives me -10 plus 4 is -6. And then -27 times -5. That is 135 minus 15 is 120. Okay? And then to change the -6 into a 0, again, I can go back to the top row since it has a 1 there and say 6 times the top row plus the bottom row is going to change this into a 0. Because +6 and -6 gives me 0. Then I get, up here I get -36 plus 4 is -32. 12 and -4 is 8. 6 times -27 plus 18 is -144. Okay? Now I'm getting some pretty big numbers, so let me show you something that might make your life easier. Just like any other equation that we encounter in math, if we want to make the numbers smaller, if we see that they're all divisible by some number, we can divide all the coefficients by the same number. So the top equation, I don't see a common factor for those, so I'm going to leave it. But the second equation, do you see anything that divides evenly into 27, -6, and 120? I could take row 2 and divide everything by 3, and that's going to give me smaller numbers, which makes my arithmetic easier. So the 27 becomes a 9, the -6 becomes a -2, and the 120 becomes 40. So now I suddenly have smaller numbers. How about row 3? What can I do? Divide by 8. Divide by 8 and you get -4, 1, and 144 divided by 8 is 18, -18. Okay? Now our goal is to change this into a 0, and we don't want to use equation 1 anymore because that's going to mess up the work that we already did right here. Okay? So if we did anything with equation 1, we're going to mess up that 0. So we only want to work now with equation 2 and 3 to try to change the -4 into a 0. Okay? So you're going to have to multiply row 2 by some number and add it to row 3 times some number to change the -4 into a 0. So go ahead and discuss how you would do that and try to change the -4 into a 0. Okay, so I'm going to go ahead and try to finish this one up with you. So again, we're trying to make this -4 into a 0. What we can do is, what's a number that 9 and 4 go into evenly? 36. So if I'm going to keep the top row, and then I'm going to keep the second row. I'm only focusing on the third row right now. And so I want to replace the third row. What I can do is multiply the second row by 4 to get 36, and the third row by 9 to get 36. And that will give me a 0 where I want. There are different ways to do this, but this is one option that will work. Let's see, I'm still. Okay, and so now when we do that, what is 4 times 9 plus -4 times 9? 0. So we end up with 0, 0. 2 times, or negative 2 times 4 plus 9?
1.
Negative 1, isn't it? Oh, no. No, you're right. It's 1 because it's negative 8 plus 9 is 1. How about 40 times 4? You might need a calculator for this. 40 times 4 minus 9 times 18. It is negative 2. Okay? Now the bottom row looks great because we have a 1 and 2 zeros, which is what we want. Okay? Now the next step is to make that a 0. And we can do that by leaving the top row the same. And then I'm going to replace this row with what was row 2 plus 2 times row 3. That's not going to change the first 2 because of the zeros. But then we have negative 2 plus 2, which is 0. And what is 40 plus negative 4? 36. 0, 0, 1, negative 2. And now we're almost there. I can fix the second row and be done with it if I divide everything by 9. So that's going to be 0, 1, 0, 4. So I took row 2 and I divided by 9. Bottom row is good. We've got the 1 where we want it and the 0s where we want it. Okay, now we have one more step to convert these into zeros. Remember, we can do that in one step by using all 3 equations. Because of the ones that we have here, I can take row 1 and add 6 row 2 and subtract 2 row 3. So that's going to give me 1, 0, 0. What is negative 27 plus 6 times 4 minus 2 times negative 2? I got 1. Did anyone else get 1? Okay. Now we have 0, 0, 1, 0, 4, 0, 0, 1, negative 2. And now we have it in reduced row echelon form because we have the 1s there and 0s everywhere else. Okay? And so now we're ready to state our answers. That is, the top row tells me what? X is 1. The second row tells me Y is 4, and the third row tells me Z is negative 2. Okay? So these take practice, but we kind of followed the same steps along the way to get the zeros and the ones where we wanted. Okay? So any questions on that example? Yes, Dylan.
Does it matter if you try to find 0 for the negative 4 or the negative 3 first?
No.
Okay.
You can get different zeros and ones in the rows. They don't have to be on the diagonal, but that is called reduced row echelon form when it's like that. But it still works to get ones in the other columns. Okay. For problem number 3, all I want you to do is write your augmented matrix and then stop. So everyone write that in augmented form. Okay, so take a look at what you wrote down. Check it with what I wrote down, and let's make sure that I have it correct before we go on to the next step. So check very carefully with all the positive and negative signs. Tell me if I have any mistakes. Is that correct?
Yeah.
Okay. Now take out your calculator. And we're going to let our calculator do a lot of the cumbersome grind work to put it in reduced row echelon form. Okay. So on your calculator, let's go to matrix. Matrix is second x to the negative 1, so it's right below the math button. And we want to edit. Okay. My matrix A is already a 3 by 4. You're going to need to change yours to a 3 by 4 by changing. Right now, yours probably says a 1 by 1, right? So the size needs to be changed to a 3 by 4 if it's anything different than that. So you're going to change the size to 3 by 4. That means it has 3 rows and 4 columns. Okay, and then press enter. And then you can put all of the numbers from our augmented matrix in the calculator. Okay, so you should end up with a matrix that looks exactly like the one I have up here on the screen. Okay, so go ahead and change it to a 3 by 4 and then start typing in the numbers from our augmented matrix. Okay, so now that we have matrix A entered correctly, we're going to quit. Second quit. So that we're on the home screen. Clear anything out that's there? We want to be on the home screen. And now we'll go to the matrix menu, second matrix, and go to the middle option, which is math. And we need to scroll all the way down until we see something that says RREF. Not just ref, but RREF. So that's option, on my calculator, it's option B. It may be option B on yours, or it might be a different one, but we're looking for RREF. RREF stands for, anyone guess? Reduced row echelon form. Okay? Reduced row echelon form, so we select that. And now we need to select the correct matrix, so we go back to the matrix menu and select matrix A. Press enter. So now it says RREF of matrix A. Press enter. And it did all the work for us and put our matrix in reduced row echelon form.
God bless. Modern technology.
So in reduced row echelon form, it's 1, 0, 0, negative 5, 0, 1, 0, negative 2, and 0, 0, 1, negative 1. Okay? So now that it's in reduced row echelon form, we can easily see our solutions. The top row means x equals negative 5. The middle row tells us that y equals negative 2, and the bottom row tells us that z equals negative 1. So if you can take the time to enter those into the calculator, it will put it in reduced row echelon form for you. Okay. Okay, when we put that system into a matrix, we have 5, 5, 2, 8, 5, 5, negative 229, 1, 1, 3, 11. And so then if we quit, and we already have our ref of matrix A up here, so if we just select it and press enter again, it gives us something that is not in reduced row echelon form. Okay? Look at the bottom row. 0x plus 0y plus 0z equals 1. So that means 0 equals 1. When is that true? Never. 0 is never equal to 1. So that means this system has no solution. These three lines do not intersect. Okay, so there is no solution. If it puts it in reduced row echelon form, then we have a solution. Okay, so that completes the notes for today.